Okay, so today we're going to talk about the programming process. And essentially, up to before today, we've been learning a lot of coding concepts. We've learned about for loops, if statements, while loops, function definitions, variables, variable assignment. We even looked at a little more theory and what's going on with scope, with the globals and the stack and all that stuff. But one of the things that, especially new students, new to programming, they struggle with, how do I get started? And that's actually a question I get from a lot of students. And like, I don't know how to get started. I don't know what to do. And what we're going to talk about today is going to help with that. So it's one of those things like, how do I get started? And we're going to show you, and we're going to do some examples, and we're going to look at some ways of getting started. And we're going to do that through the programming process. And the programming process, which again is these four things here, but I broke them out into two areas. And the reason for that is there's two parts. First part, incremental coding, iterative development, is basically actually editing code, modifying code, and doing code. And we'll talk about what those processes are. And then the testing and debugging portions of it are how to both ensure your program works and how to fix it. And it's just a process. This is actually a process for developing programs. It's very similar, if not identical, to some of the processes I use just internally. I just don't talk about them much because it happens in my head. But I've been through companies that have formalized versions of this process. And this is more of a theory of how to code, like how to actually write code. Specifically, how to write code that works, and to be confident that your code works. Because there's nothing worse than submitting something going, I don't know if this is going to work. Now, we do give you the auto grader, and the auto grader helps you to sort of understand whether your code works or not. But in future classes and in some assignments, you may not get everything auto graded. And in fact, in CSE 12, when I taught CSE 12, which is data structures, we hid the tests. So you never saw your grade until after we graded it, which means when you submit it, you have to be confident it works. And this is the way to be confident that it works. And so we have this process, and we have the first two parts, incremental coding. And what we're saying with incremental coding is, do not write your program at one time. I've seen a lot of beginners actually do this. They'll write their program, everything. It could be 5 lines, it could be 500 lines. They'll write the entire program, and then they try to test to see if it works. And that's just a recipe for a lot of stress, and also a recipe for disaster. It just doesn't work. Instead, you want to break your program into smaller parts, right? You want to actually write small pieces of your code. So you write a few lines, make sure it works. Write another few lines, make sure it works. And so we call that incremental coding. You're adding small bite-sized chunks, and over time you develop this larger and larger program. But each step of the way, you kind of confirm that it's working. Eventually, you're going to get to a point where you think your program is good enough. Like, I feel that the program is now working the way I intended it to work, or the way I was told it should work. But you may not be confident yet that it's working, but you're pretty reasonably sure it is. But you really want to make sure it works completely, and you may find that it doesn't. And so you go through the testing and debugging process, the bottom two sections. And during testing, we do multiple test cases with your programs to ensure that the program works with all different types of conditions. And if you find that it doesn't work, like, what happened? I don't know. Let's figure out what's wrong with our program, what bugs that you have. And then we look at this process of debugging is, how do I find the problems and how do I fix those problems? There's multiple types of problems you have to deal with when debugging. Some is that you get, errors, and sometimes you just get bad answers, and you have to really dig into your program. That's debugging. That's like, how do I do that? We're going to talk about that process as well, because that's an important process. But you don't know if your program doesn't work if you don't test. And so you need to test your program, figure out if it's working, and then fix it. And so you use all four of these. And I haven't really talked about iterative development yet. There's a section on that. We'll come back to that because that's also an important part of programming. But I want to do an example, kind of show this whole process through an example. We didn't do this because we didn't have time. Hopefully you did it as homework. In fact, show of hands. Who did this one as homework? Just a quick show of hands. Anybody actually work on this? I can't remember. I think this was like while loop. So this is lecture 7, which was last Wednesday. One person raise their hand. Okay, so one person kind of has been through this. The rest of you, this is going to be new. And that's fine. I want to basically go through this process. I want to use the process of, well, these 4 processes, or at least a couple of them, to kind of go through. And specifically, I want to look at iterative development combined with testing. So this program is going to take some kind of input from the user. And it's going to continue to run until the user enters 5 9s in a row. We don't allow negative numbers. But we do consider 0 to be not a negative number. So if you look at this example here, that's 3 numbers. 30 divided by 3 gives you 10. So 0 is a valid entry, but negative numbers are not valid entries. Those top 2 are actually ignored. So we have this, what this is called a specification, or also a write-up. It's a program that we want you to write, specification. And let's actually take a look at how it's going to run, or how it's going to work. Let me actually, I forgot to open idle. And you may have seen me do this in lecture, and there's a reason for it, but I want to do this kind of a little more thoughtfully, and how we're going to run this and how we're going to write this. And just to get started, I'm going to make sure I save this. And this is lecture 10, and call this rainfall. Okay. So let's think about what we're going to do. We have a lot of, I mean, if you just look at this and you think, man, there's a lot of things in here. And your first inclination might be, let's write the whole thing. You might think this is easy. You may not know how hard it is. You may not even know it's hard at all. And it may not be hard. But you really should break it down into small, simple steps. And the first thing we want to look at is, well, user input is central to this whole thing. So let's do some testing. Let's do some input. We know how to get input. And we look at the text. It says, we're going to prompt with the word rainfall. And, okay, well, we don't want to save that as a variable, right? We want to save that as a variable. And just to make sure it's working, I will print it out. I just want to know it's working. And I save it and run it, and I should be able to see that it works. I write 10 and it prints 10. Okay. So far, we're working properly, right? I mean, now we have input from the user. That's like the first step. If you think about the process of incremental coding, we just did the first increment, and we're further along than we were before. We just did the first step. But now I have to think about, well, I have to be able to get a bunch of numbers, not just one number. I need a bunch of numbers. And we can think about how to do that. And we know we can do that. You know, basically, we're going to get input from the user until they enter 999. So let's just do a loop. I'm just going to do an infinite loop right now. We'll talk about how to do that later. And while we're there, we know we have to actually, and by the way, I keep flipping back to this because it's important to know what you're doing. We know we're going to sum up the information and then divide it. So we're going to track a total. Well, we know how to do that. We just assign a variable, and then we're just going to add whatever rainfall we get directly to that. And then I don't really care about the rainfall anymore. Now I'm interested in the total. Now, there may or may not be a problem with this code, but that's why I'm going to run it. I don't know if I have a problem yet, so I test it. If I add 10, oh, I have a problem. I didn't really have to think about what the problem is at first, but now I need to look at this and say, what happened? Line 5, and by the way, if you want to know what lines are, show line numbers. So options, show line numbers. Line 5, and it's also printed right here. Oh, I tried to add, remember the input takes a, or returns a string, and I added an integer to a string, or I tried to add, this is an integer, string, doesn't work. So now I have to make sure I do a cast, a type conversion to an integer. And we're going to assume that only integers are going to be used in here, no floats. We could have put a float there, but I choose to say we're going to only handle integers for now. So again, save and run. And let's try it again, 10. Okay, and we printed 10, so 10 plus 0 is 10. 20, 10 plus 20 is 30, that's valid. 30, 30 plus 30 is 60, 40. The total variable works as expected, but I don't have any way to end the loop. If I actually put 999 in there, it actually added it. So the only way to terminate this is the hard stop, which is the keyboard interrupt, Control C. So, okay, I have my total working. I have my input working. I'm not stopping. So let's add the stop in there. And we want to add the stop before we actually increment the total. So before we increment the total, we need to exit. Well, we know how to do that. We're looking for the number 99999. We're just going to break. Now, if I enter 999, this will end the loop. So let's test it. Let's make sure, again, every step of the way. I'm testing every step of the way. Small changes. By the way, when you're doing small changes and you break something, guess what? You know where you broke it because it's the stuff you just added. Now I have confidence that everything else I've added works, but maybe this new thing doesn't work. I don't know yet. But if it breaks, at least I'll know because it's a new thing I added. Seems to be working. Now let's see if it stops. It did. And the total didn't change. The total stayed the same. So we didn't have the 100,099. We still have 60. So now this part is working as expected. So every step of the way, I'm confident that my program is currently working. Okay. So I have a total. I'm adding, I'm stopping. I have this part done. But I need to count the number of days and I need to be able to do division. So let's count the number of days, right? How many days of rainfall did I have? We're just going to count them. But remember, we're not going to count negative numbers. We're going to ignore negative numbers. Let's actually put the ignore negative numbers thing in first. Because right now, let's actually run it. What happens right now if we run this? I put 10 minus 10. My sum went to 0. 30 minus 30. My sum went to 0. My total is 0. I don't want that, right? So we need to skip that. And before I do the count stuff, I'm just going to ignore negative numbers, which means I should only add. And remember, we consider 0 to be a positive number. So now, if rainfall is greater than or equal to 0, only then do I add. Well, we can test that on its own real fast just to make sure it worked. Because every step of the way, I just want to fix my little problems. Whoops. $10 minus 10. It stayed 10. 20 minus 20. It stayed 30. Okay, so now we're skipping negative numbers. Great. Now let's put in the count for days. That's just another counter of some sort. We'll start at 0 and we're counting. We're starting at 0 just in case we don't actually enter anything valid. There is a situation where that can occur. They don't enter any data, or if you enter all negative numbers, you should get no data. So that is a situation. So now we're counting. But when do we count? Well, we only count when it's a non-negative number. And just to make sure we know it's counting, we're going to use a print statement. By the way, you notice I have print statements. I'm just using these print statements constantly just to see what's happening. Now let's run it. Let's see if this works. 10, count is 1. Minus 10, count is still 1. 20, count is 2. Minus 20, still 2. 999, count in total are still there. Perfect. So we're making progress. We're getting much closer. By the way, you may have noticed this, we call this also like organic development. It's like an organism that just slowly grows. I'm sure some of you have played with those crystals, that you grow crystals in an aquarium or something. It's the same concept. Over time, our program just gets bigger and bigger organically. Just as we add stuff, it just gets bigger. Instead of us trying to just write it all at one time and then not knowing any of it, what parts work or not work. Okay, so now we just have to print our final calculations. And I don't need these print statements anymore, but I'm going to print some other stuff out. So I'm just going to move these out of the loop. So we just need to do the final calculations. And so after the loop is done, so once we hit 999, the loop ends. We need to print some stuff. What are we going to print? Number of valid days equals 2, average rainfall equals 15.0. So we need to print those two things. Let's just use these print statements. I have already stole them. So number of valid days equals, and we'll concatenate that with the counts. Remember, to do concatenation, we have to turn it into a string. So the number of valid days is the count. Then the next prompt said average rainfall equals, and again, oh, I don't have an average. I have to calculate an average before I can put it in here. I can't just put the total in here. I need to do some calculations. So let's compute the average. Well, what's the average? Total divided by count. That'll give me a number. Turn that into a string, and we'll print out the average. And just make sure my text matches. Average rainfall equals, number of valid days equals, my text matches. And run it. And so if I add 10, 20, 30, notice it's not printing anymore. Remember, I took that away. 100 divided by 4 should be 25. Number of valid days is 4. That's valid. That's correct. And 25.0. That's also correct. Okay, so it looks right. All right. So we're done, right? Do I need to do anything else? We should probably test some of these other cases. But let's look at some weird things, right? At this point, we may think we're completely done. And if we go back to our thing here, we might say, well, I've done my incremental coding. I look done. It seems to work. But now we need to go to the process of testing. We need to say, well, it looks done, but we have to consider some other cases. We could test more cases. In fact, when you're given a write-up and you're given 4 different cases, you test every single one of these cases because we're told to test those cases, which means we're definitely going to test them. However, there's other things, what we call edge cases. There's common cases and there's edge cases. Edge cases are the weird things that maybe we wouldn't think to test. But regardless, we want to make sure our program works in every case possible. And so let's look at edge case. I can think of one edge case that wasn't in here. There's an edge case missing that's not even in here. And that is all negative numbers. Minus 10, minus 20, minus 30. What's that going to give us, right? We don't count them. There's no total. 0 divided by 0. What's 0 divided by 0? Ooh, 0 divided by 0 is an error. So let's actually follow this to line 13. Right here, it's also printed out, average total divided by count. Arrow says division by 0. So why? Remember, total. Ignored, ignored, ignored. Well, that's a 0. Count. Ignored, ignored, ignored. It started at 0, never changed, stayed at 0. So we divided by 0. We would actually have the same error. Whoops. Sorry, wrong thing there. We would actually have the same error if we didn't do anything. Remember that bottom case down there? 9999, no rainfall. We actually get the same problem. So the count is 0. In both cases, whether I do all negatives, I get a 0. Remember, valid day is a 0. Look at right there. And yet, valid day is 0. And so now I have an error. I don't want this error. By the way, this little thing, we're going to talk more about it, but this is the process of debugging. We're fixing problems that we found through testing. So we have to handle this case, and we were told exactly how to handle this case. If there's no rainfall, we don't print number of valid days. We don't print the average rainfall. We print no rainfall. So now we can put in something here and to say, oh, if the count is greater than 0, then, well, actually, let's just do one part first. Let's do this. We can do an else here, or we could be more specific and put an elif here. Either one of these will actually work. That should get rid of our divide by 0 problem. Because now this will never be 0. If it is 0, it actually won't print the average rainfall. So let's just run a quick check with all 9s. No rainfall, but, and I knew this was going to happen. I did it intentionally. We shouldn't have printed that. So we really need to go back again, put that inside the if. Now we run it, 99. And now it matches the write-up, right? Write-up says no rainfall, and that's it. And that's what we have. We have that with no rainfall. We actually matched that perfectly there. Well, let's try our other edge case. Now that we had that weird edge case, hopefully we handled it. -10, -20, -30. Whoops, that was not 30, but regardless, that should still do nothing. Still no rainfall. So we actually just did this, and I can't think of any other problems. I'm not saying there aren't other problems, but I tested multiple things. I should still go through and test all these other situations just to make sure they work. But this is an example of going through this process, right? We used incremental coding. We didn't really do iterative development. We'll talk about that in a minute, but we did incremental coding, and then we did multiple testing multiple times. And then we did some debugging, testing at the end, and some debugging to fix problems, and then back to incremental coding, testing and debugging. And eventually we end up with a fully working program. So as a program gets more complex, we need to use these processes in an effective manner to achieve what we want, which is a fully working, hopefully bug-free program. And all these processes are interconnected. You don't just do one thing at a time. You kind of do them all together so that you end up kind of completing the whole thing. By the time you get to the end, you're confident it works. So we write a little bit of code. We test it to see if it works. So we go incremental coding to the testing phase. If you test it and you figure out it's not working, Then you go to the debugging phase, figure out why it's not working. And then after you figure it out, you go back to the incremental coding phase to actually fix it. And it's helpful as you're going through the process to understand which stage you're in and just to know what you're doing at any point in time. So where am I at? Just so you know with your incremental coding, iterative development, testing, and debugging. And we really didn't do iterative development here. We just did incremental coding. And the difference between these two is that incremental coding is when we write the first version of the program. So at this point, I've written the first version of the program. Incremental coding, we split the program into small parts. We do one at a time, and then we develop our first version. Once we develop our first version, when we can say that incremental coding is done, we finished the first process. But then we may not be totally done, because then we may have to do some testing, figure out some problems, see if it wasn't working, like our negative numbers example. And then we do some debugging, and then we go back to incremental coding and we fix stuff. Or we go into iterative development. Maybe we find out that there's some other things we need to do. Iterative development takes a particular version, like say the first version, and what's called we iterate over it. And we iterate over it multiple times to bring it to an area where it works for all cases, all possible cases. Or if we want to change how it works, like maybe we don't, maybe a new write-up comes out that says, well, what about this case? You should do it with this case as well. And then we'd have to fix that. And so that's what incremental coding looks like, right? It kind of looks like that. Any questions on the whole process? This is kind of the whole process. And that created this whole thing here. So we wrote a version, we fixed a version, we kind of went through the whole thing there.